Today we're going to graph basic rational functions. A rational function has the form f of x equals p of x over q of x, where p of x and q of x are polynomials and q of x cannot equal 0. That p of x over q of x may look familiar from when we were doing polynomial long division. The parent graph for a rational function is 1 over x. Its vertical asymptote is at x equals 0, because if x were equal to 0, you'd have 1 divided by 0, and you can't divide by 0. The horizontal asymptote is at y equals 0, because 1 over x, no matter what the value of x is, will never equal 0. That makes your domain and range all non-zero real numbers. In interval notation, we write that as negative infinity up to 0, union 0 to infinity. There's no bracket around the 0 because it's an asymptote. We always use parentheses for asymptotes because that is the definition of an asymptote. The graph approaches, gets super close, but never actually reaches that number. Any function of the form g of x equals a over x, where a does not equal 0, has the same asymptotes, domain, and range as the parent function, 1 over x. 1 over x is a rational function that is also a hyperbola, something we'll get more into when we learn about conics in pre-calculus. To begin, graph g of x and compare it to the parent graph. State the domain, range, and asymptotes. Because both functions are in the form a over x, our domain and range and asymptotes will be the same as the parent function 1 over x. The difference between 4 over x and 1 over x is a vertical stretch by 4. So let's graph the parent function, fill out a table of values for the new function, and see how they visually compare. A vertical stretch affects the y values. So if x is 1, then y will now be 4. At x equals -1, y will now be -4. To get a slightly better picture, let's plug in -2 and +2. 4 divide -2 is -2. 4 divide 2 is 2. The branches of a rational function that is also a hyperbola, like this one, are symmetric if these points are symmetric about the origin. What do I mean? Plug in 4 and -4. Now draw your new graph. For part B, we have a vertical stretch by 6 and a reflection in the x-axis because of the negative. So you can see a vertical stretch is just going to pull the branches just further away from the origin faster. To graph translations of simple rational functions, we have y equals a over x minus h plus k, where a is your vertical stretch or shrink, and if it's negative, that includes a reflection about the x-axis, where h is your horizontal shift, indicating your new vertical asymptote, and where k represents your vertical shift, meaning your new horizontal asymptote. Domain and range are the same, except instead of 0 being the asymptote, h is the vertical asymptote and k is the horizontal. Let's graph -4 over x plus 2 minus 1. This would make a -4, h -2, and k -1. The horizontal shift is our new vertical asymptote. The horizontal asymptote is y equals -1, your vertical shift. Our domain is going to include everything except -2, and our range will include everything except -1. If I were to compare this to f of x equals -4 over x, the one without those shifts, I would get these points. That is the graph of -4 over x. So I'm going to take each of these points now and translate it 2 units to the left and 1 unit down. And now we've graphed g of x. You could leave the graph of f of x on there. I just wanted to erase it, or most of it, so that you could see more clearly what g of x looks like. For graphing other rational functions, other basic rational functions would be a linear function over a linear function, as seen here. Your vertical asymptote is whatever makes that denominator equal to 0, right? So cx plus d equals 0. If you solved for x, you would get negative d over c. So that's why that is your vertical asymptote. Your horizontal asymptote, when the degrees of the polynomials in the numerator and the denominator match, will be the leading coefficients, a over c. Let's go ahead and graph f of x equals 2x plus 1 over x minus 3. Then state the domain, range, and asymptotes. The vertical asymptote is whatever makes our denominator equal to 0. That would be positive 3. The horizontal asymptote for rational functions of this form is leading coefficient over leading coefficient. That would be 2 over 1, so y equals 2. So your domain will be everything except the vertical asymptote, and your range will be everything except the horizontal asymptote. Now I need a few points for the branches. I'm assuming the branches are here and here because we do not have a negative on top, so no reflection, but I still need some points. So I'm going to plug in the x values around the vertical asymptote. 1, 2, 4, 5. Now let's graph our points. You could also plug in more values, but the asymptotes are kind of like boundaries that help me build the rest of the branches. So this one will go up and then hug the horizontal asymptote when we get down here. This gives me an accurate enough sketch. Our final option is to rewrite a linear over linear rational function in the form a over x minus h plus k, the transformational form. How would we do that? We would use long division. So let's divide our rational function to rewrite it in this form. We'll take the numerator and divide it by the denominator. X goes into 3x 3 times. Subtract. So 2 is your remainder. And we write that over the divisor. So if 3x plus 5 divided by x plus 1 is equal to 3 plus 2 over x plus 1, g of x rewritten in the form a over x minus h plus k could be rewritten as remainder plus quotient. Now you know that a is 2, h is negative 1, and k is 3. Your vertical asymptote will be x equals h, the horizontal shift of negative 1. Your horizontal asymptote is dependent on k, the vertical shift. And remember, your domain is everything except the vertical asymptote, and your range is everything except the horizontal asymptote. Graph your asymptotes, and then we'll plug in some values. They also asked me to compare to f of x equals a over x. In this case, that would be 2 over x, since our vertical stretch is 2. So let's graph 2 over x. If I took each of those points and translated it 3 units up and 1 unit to the left, then I would get the new points for g of x. Another way that I could do it is that I could visualize how far each of these points is from the intersection of vertical and horizontal asymptotes. So this is 1 unit from the vertical asymptote and 2 units from the horizontal asymptote. So when I translate that point, I will go 1 unit from the vertical and 2 units from the horizontal. This one is 1 unit above the horizontal asymptote and 2 units to the right of the vertical. So I'm going to go 1 unit above and 2 units to the right. However you decide to translate these points is up to you. But now we have a clearer picture of g of x. And compared to 2 over x, we've shifted to the left 1 and up 3. And that is graphing basic rational functions.